Hey there. What's something more annoying than trying to use a website and then having to pass a CAPTCHA proving you're not a robot? Well, what if that CAPTCHA turned out to actually be some trick from some hacker who then gets full access to your computer? So, believe it or not, that scenario is actually possible. Now, this kind of cyber attack isn't new, but I feel like I've seen an increase in the amount of people reporting it. So, I thought it was worth diving into a little bit. In this video, I'll walk through a little real world example of this type of attack in action, and then I'll add on a little demo recreating some of the important parts in the lab environment. To get started, let's talk about how this attack can work at a high level. The weakest link of any IT environment is usually the end user. If a bad guy can trick someone into performing some action, also known as social engineering, they could bypass many defenses that would otherwise stop them. For example, instead of exploiting some convoluted software vulnerability that requires a chain of complex steps, the attacker could simply just convince a user to run a malicious file, or even just give up their credentials. In this way, social engineering can dramatically lower the required attack complexity because the victim essentially opened the door themselves. In the case with these fake captchas, a user could be browsing the web, then they could be redirected to or accidentally navigate to a malicious website. That site could look like anything, it doesn't really matter. But once on that site, the user sees a captcha pop up. When they check that they're not a robot, a second stage then pops up and asks the user to follow some steps. Then the user unknowingly pastes a malicious command into the run dialog box and runs it. And if the attacker's payload wasn't blocked by anything like antivirus or AMZ, the system's compromised. As far as the general attack flow goes, it's really that simple. To see a real world example, I'll use a site called any.run. If you felt like checking out any of the AnyRun examples that I'll show for yourself, you can find links to them on the X post that I have on screen now. Okay, for the first example, we can see the user going to a suspicious looking website, and of course after a little bit a fake captcha box pops up. When that's clicked, they get a pop-up for fake connects verification steps. Then they open the run dialog box, paste in the command and run it. If we look at about the 2-minute 45 mark, we can see PowerShell dropping some DLL files inside of the user's temporary directory, and it's common for malware to work out of this temp directory. Shortly after, a malicious setup.exe spawns, and then eventually searchindexer.exe. If we look on the right, we can scroll down to process ID 3464, and that's the original PowerShell command that the user ran. It's base 64 encoded, so we can just put that into something like CyberChef to decode it. So the command was downloading something from that tiny URL and then executing it. We can plug that tiny URL into a URL expander and see that it was downloading something called v.txt. If we look at the graph view, we can see the point where the user tried to go to that initial website. If we plug that site into VirusTotal, we can see it's been flagged by a decent amount of vendors as malicious and phishing. Next, we can see a process trail left behind by that original PowerShell command. There's a few things here, but the most interesting is this program called searchindexer.exe. AnyRun's threat detection rules identified that this file is associated with something called Luma. And Luma is actually a very well-known information stealer. Here's an article. Microsoft says that it targets data in browsers and things like crypto wallets, and will even drop extra malware on a system. It's commonly sold as a malware as a service and used by major threat actors. And if we look back on AnyRun in the modified file section for searchindexer.exe, we can see that this program interacted with the user's edge history and browser cookies, so that lines up with it being an information stealer. There's a lot of information here, but I don't want to get too far into the weeds, since after all my focus was supposed to just be on those fake captchas themselves. But the point's there. This Luma malware was able to quickly compromise the system due to one mistake of falling for that fake captcha. For another quick example, I have this one. A user navigates to a sketchy website that looks like it's impersonating some sort of Exodus crypto wallet with a pretty good chunk of cash in there. Same initial steps as before. A series of fake captchas pop up, and they ask the user to paste a command into the run dialog box. Then shortly after, PowerShell runs and starts executing things. Interestingly though, on this one, it looks like part of the attack failed since there was a WScript error pop up. There's not as much on this one as the other, but on the right, one thing we can see is that WScript was trying to execute something called a.vbs from the user's temp directory. Now, WScript is a Windows built-in program to run scripts, and VBS is the extension for Microsoft Visual Basic Scripting Language. We can also open up the PowerShell part and see that AnyRun's detections caught it as a fake captcha. And if we look at the full command, we can literally see a comment saying, "I am not a robot," to try to make this thing look more convincing to a victim. And that's really it for this example. If I look at the graph view, I can see that WScript had no child processes, and that lines up with the part of the video where WScript threw an error. So whatever was in that a.vbs was probably malformed. You don't need a whole lot to recreate these fake captcha attacks. There's a whole lot of ways to do this, but this is just how I'm doing it. I'll be setting up everything inside of a Linux Mint VM, and my victim will be another VM running Windows 11. On my Linux Mint, I'll be using VS Code to put it all together, but it's just an IDE, so you don't need it for this. I know I'll need 4 different terminal windows, so I'll just go ahead and open those in VS Code. I've made 5 directories to organize my files, so I have fake captcha as the main root directory holding the whole project, Beacon directory has postlistener.py, which listens for beacons coming from that target machine. Main web, which has all the files for the initial fake website, as well as a subdirectory that will hold my web certificates. Then second stage to host the second stage VBS script, and I'll go ahead and have each of my 4 terminal windows open on the main directories. I'll use 3 different web servers running with Python, one to host the initial fish site, one for the second stage VBS script that will be downloaded after the captcha part, and one to listen for incoming beacons from the target. The initial phishing site will be using HTTPS, and there's an important reason for that. In the AnyRun examples I showed, once a user clicks on the fake captcha, the malicious PowerShell command is automatically copied to that user's clipboard. So JavaScript can actually copy text to users' clipboards directly from the browser, but during my testing I found that that is only possible when the browser is in a secure context. And one of the requirements for that context is running HTTPS. To deal with that, we can use a tool called mkcert. This is used to easily make web certificates, and we can use those to run our fish site on HTTPS. On Mint, I just installed it by running sudo apt install mkcert-y, and I'll make a directory to hold my certs. Then run ip-bra to grab our Linux IP, then run mkcert followed by that IP, and lastly, I'll rename them for clarity. So I'll rename the key one to just key.pem and the other one to cert.pem. Now I can show the HTML behind the main fish site. This is what I have in my main index.html file, but of course this could be shortened down quite a bit since I just have a lot of fluff for aesthetics. Here's a different example with fewer parts. You don't need any CSS if we just care about testing functionality, so this link calling a CSS file could just be left out too. I won't be going over my CSS file since it's not technically needed. Okay, this is my JavaScript file just called script.js. From the top, it waits for the web page to load, then after 2 seconds, it makes a blur overlay and the first pop-up visible. Then here's the verify bot function that was called when a user clicks the checkbox. I have 2 variables to make up the full malicious command. So this is very similar to my last AnyRun example. It opens PowerShell in a hidden window, then defines the URL to download a VB script from one of my web servers, sets the save location to the user's temp directory, uses PowerShell's invoke web request to download the file, and then runs it with wscript. The fake code variable is there really just to hide a bulk of the script when it's being pasted into the run dialog box. Those 2 variables are concatenated into the payload variable. Next line, the payload is written to that user's clipboard, and finally it'll hide the first pop-up, then display the second one. And then at the end there's a little bit of error handling, but it's not technically needed. Next I'll show the second stage loader.vbs. I have that in a directory called second stage. This is pretty simple too. It runs 2 different PowerShell commands. The first one is a reverse shell. It's base64 encoded, mainly so I didn't have to deal with extra quoting and escaping characters. I pulled this right off of a site called revshells.com. It's just the base64 encoded version of option 3. Of course, I had to specify my Linux computer's IP address and the port to listen for the shell on. The second command beacons back to my web server once the system's been compromised, and it does that with a post request. Something that I thought was cool to add to this beacon was that I have it grab the computer's host name and the username that ran that fake captcha. After each command, I make sure to add a 0, which means that wscript runs them in a hidden window. I can show my beacon web server that waits for the post request. Not a lot going on here either, but it reads inbound data and then breaks that data up. It makes it look pretty. Then it'll send an HTTP response code 200 to the target machine. And of course, it's listening for inbound external connections on port 8080. I didn't set up any certificates for this listener. To host the main phishing site, I've set up a file called web.py. The site does need to be HTTPS, so I had to import the SSL module at the top. And I have a section to import those web certs that I made with mkcert earlier. And lastly, it listens for inbound external connections on port 443. Everything should be in the right place now, so I can start turning it all on. So I'll go to my first terminal and run sudo python3./web.py. That turns on the main site. In the second terminal, run sudo python3./postlistener, and now my beacon listener is up. In the third terminal, I want to make sure that I'm in the same directory as my VB script. And I'll make a simple Python web server with sudo python3-m http.server80. So that's running the server on port 80. And lastly, I'll need a netcat listener to catch that reverse shell from a target. So I'll run sudo nc-nlvp1337. And finally, all that work was building up to this. I'll get on my Windows machine and make sure that antivirus is turned off. And then I head to my HTTPS site. As expected, I see the CAPTCHA, followed by fake verification instructions. I'll follow the instructions and then paste my clipboard into the run dialog box and hit enter. Then I head back to my Linux Mint. In my main web server terminal, I can see web access logs going to the fish site from my target. And in Beacon, I can see beacon information. He received the new post, here's the target's IP, the header info shows that the user agent was PowerShell, there's a host field, and in the post body we can see the target username and user account that ran the fake CAPTCHA. In the second stage one, I can see access logs showing VB script was grabbed. And lastly, in my shell window, it says connection received. So I'll run hostname and who am I to see where I'm at. So this system was compromised. All right, that's it for this video. I think it's one thing just to hear about some new cyber attack and a completely different thing to try it out for yourself. And I think getting in there and playing around with stuff can be very important for the blue team side of things. If you look back at those X posts that I showed earlier, they give a lot of information on how the good guys can better detect this sort of stuff in their logs. And it should go without saying, but never paste random commands from a website or any website into your run box or any terminal, especially not ones from a CAPTCHA. Hope you learned something.